Hello everyone, my name is Diksha and I am from the Bodhi Academy. In last part of chemical reactions and equations, we have seen about how chemical reactions takes place and how we come to know that the chemical reaction has taken place, and how to write the chemical reactions and chemical equations, and also how to balance the chemical equation. Okay, so today we are going to see the different types of chemical reactions. Now in general, we have many types of reactions that are taking place. Okay, but today we are going to see the few main types of reactions that takes place in our day-to-day life. Okay, and we will learn more about them. So first reaction that we are going to study is the combination reaction. Now what is combination reaction? Combination reaction means when two or more reactants combine to give one product, only one single product, that is called as combination reaction. Okay, so through example we will see what is the combination reaction. Now if we take calcium oxide, and combine it with water, okay, we will get calcium hydroxide. Okay, so this is the combination reaction, means two reactants are combining to give only one single product. So this is the example of combination reaction. Okay, now combination reaction, when the combination mostly when combination reaction takes place, it releases heat. Okay, it releases heat. So when the if the reaction is taking place and giving out heat or releasing heat, the reaction is called as exothermic reaction. Okay, so heat is given out in this type of reaction. Now for example, we have burning of natural gas. Now what is natural gas? It is methane, right? So when methane is burned, it is reacting with oxygen. So when methane is burned, that is CH4, with oxygen, what we are getting? We are getting carbon dioxide. Okay, so we are getting carbon dioxide plus water. So this is the example of what reaction? Exothermic reaction, and which comes under combination reaction. Okay, so this was all about the combination reaction. Now next reaction we are going to see is the decomposition reaction. Now what do you mean by decomposition reaction? Now here the decomposition will take place. Okay, now in combination reaction we have seen that two or more substance will give one single product. So here we will see the opposite of it. That means only one product, only one reactant, okay, it will decompose. It will decompose to give two or more products. So in combination reactions, two or more reactants were giving only one product. And here what we can see is only one reactant will decompose to give two or more products. Okay, so now what is decomposition reaction? When two or more when one reactant is giving two or more products. Now for example, we have ferrous sulfate. If we have ferrous sulfate and if we try to heat it in a test tube, in a dry test tube, what we will see after heating, the color of FeSO4 was green, and after heating it, the color changed. Okay, so the change of color took place in the decomposition reaction, and that by that observation we can say that the decomposition reaction has taken place. Okay, so we will write the decomposition reaction. So FeSO4, which is ferrous sulfate, on heating will give Fe plus SO4. Means this individual compound will give two or more products. Okay, so ferrous plus sulfate. So this is the example of decomposition reaction. Now when decomposition reaction is carried out by heating, it is called as thermal decomposition. Okay, and also heating means also we can take sunlight. Okay, so when silver chloride is exposed to sunlight, what do we observe? That we get it turns gray in color. Okay, when silver chloride is exposed to sunlight or when it is placed in sunlight, it turns gray color. Color is changed to gray. So why does this happen? This happens because silver chloride, okay, in presence of sunlight, it will turns into Ag and Cl2. So this is also the decomposition reaction. Means the silver chloride is in presence of sunlight is giving silver and chloride individually. Okay. Also this is happened with silver bromide. So this can be done with silver bromide also. So in place of Cl we can write silver bromide. Okay. So this in presence of sunlight will give you 2 silver plus bromine 2 molecule. Okay, so this was all about the decomposition reaction, and the application of this that is used in photography. So these reactions can be used in photography. So that is the application of this decomposition reaction. Now we will see the third type of reaction, which is displacement reaction. Now, the word itself, displacement, tells us more about the word what will be there in the reaction. Okay, so let us discuss one experiment and try to understand what happens in the displacement reaction. Let us take 3 iron nails. If we take 3 iron nails and on the other side take 2 test tubes, and in each test tube put 10 ml of copper sulfate solution in each test tube. Okay, and put the 2 nails in one test tube containing copper sulfate solution and other test tube keep for comparison. Okay, so after 20 minutes of observation, what do we see? That the iron nails, which were silver gray in color first, okay, they turn to brownish color. A layer of brown coating of brown color is observed on iron nails, and the solution or the copper sulfate solution in which the iron nails were placed, it fades. Okay, initially it was blue color, but after putting the iron nails it fades. So what happened in this reaction? So in this reaction, iron being more reactive, okay, so iron is more reactive than copper. So iron displaces copper from the copper sulfate solution, and the copper sulfate solution fades, and the coating of brown color will appear on the iron nail. Okay, so this we can write as iron when mixed with copper or put in copper sulfate solution, it will give ferrous sulfate solution plus copper. So this iron will displace copper from its solution, and this iron will combine with sulfate, and this will go as individual element or individual atom. Okay, so iron will combine with sulfate because it is more reactive. So when it is combining with less reactive element, it displaces the less reactive element and it combines with sulfate. So it is giving ferrous sulfate plus copper. Okay, so this is the example of displacement reaction. Okay, now next is the double displacement reaction. The third type of reaction is double displacement reaction. Now in displacement reaction, we have seen that iron is displacing, or one element is displacing other element from its solution. Okay, so what is double displacement? So here the displacement is taking twice, or double displacement is taking place, not only once. So here let's discuss one experiment and try to understand. Okay. So if we take sodium sulfate and barium chloride, okay, three solutions in each test tubes, and if we try to mix both the solutions, what will happen? A white color powder is formed which is not soluble in water or in that solution. Okay, so that white powder is called as precipitate. Now when the reaction is taking place and when the powder is formed in that reaction, it is called as precipitation reaction. Okay, now we'll try to write the reaction how it takes place. So Na2SO4, which is sodium sulfate plus barium chloride, it will give you barium sulfate plus 2NaCl. Okay. So sodium sulfate when combining with barium chloride is giving barium sulfate and sodium chloride. So the sodium metal is combining with chlorine and sulfate and barium are combining. So in this reaction, both the reactants, the ions are getting displaced with each other. Okay, so two ions are getting displaced with each other. That's why it is called as double displacement reaction. Okay, so the reactions in which ions in the reactants get displaced with each other, it is called as double displacement reaction. Understood? Okay, so this was all about the double displacement reaction. Now next we will see about redox reaction, that is, which is oxidation and reduction reaction. Okay, now in this reaction, what do you mean by redox? Redox is the shorter term we use for oxidation reduction or reduction oxidation. So in this reaction, we will see that one substance is getting reduced and other is getting oxidized. So when we combine both the terms, we get the term as redox reaction. Okay. So let us discuss one experiment. If copper, okay, if copper is heated, the oxygen gas reacts with it. Okay, so when copper is heated or copper is exposed to oxygen, okay, what we can see is a black color coating or black color layer of copper oxide forms on the copper, okay, copper metal. So this black color coating or black color layer is called as what? Is called as copper oxide. So this is the when copper gets oxidized, the layer is formed. Okay, so copper when reacts with oxygen, we get copper oxide. Okay, we get copper oxide. So this is the layer or this is the coating which we get on copper after oxidizing. So this is the oxidation reaction. Okay, and next when that copper oxide which has black coating is treated with hydrogen, or when hydrogen gas is passed over the solution or the product what we are getting, again the copper oxide will gain brown color and it will turn to copper. Okay, it will turn to copper plus water will release. So after combining again the copper with hydrogen, we are getting copper oxide with hydrogen, we are getting copper and water. So in this we can see that copper is getting reduced here. Okay, so here the copper is getting reduced and here copper is getting oxidized. So in both the cases, if we combine both the terms, so in one we are having copper is getting oxidized and other copper is getting reduced. So when we combine both the terms, it is called as oxidation reduction reaction or the redox reaction. Okay. So the substance which getting oxidized is called as the substance which getting oxidized. Okay. It is said to be oxidized, which undergo oxidation. Okay, and substance which undergo reduction or which is getting reduced, it is called as the reduced substance. Now I'll try to write one reaction. So here what we can see is copper is getting reduced and hydrogen is getting oxidized. Okay, so hydrogen is getting oxidized here and copper is getting reduced here. So we can see here two reactions are taking place. So this reaction we can call as redox reaction. Okay, so this was all about the redox types of reaction. Now we have seen all types of reaction till now, the main types of reaction. Okay, so this was the 5 main types of reactions in this chapter. Now next we will see about one important topic, which is corrosion. Now what is corrosion? We have when we buy new iron articles or copper or metal, okay, when metal articles are brought, first they are shiny, they have luster, okay, and what we observe after some time or after few days, that they are getting some layer, okay, some different color layer. So why that happens? For example, say iron, okay, they're getting brownish color layer. You all must have observed it, okay. So that brownish color is called as rust. Now why do ions get that rust? Now if iron or metal articles or other articles of iron, copper, okay, so when when they are exposed to air, moisture or acids, okay, so when they are exposed to such factors, what happens is they get some layer, and that layer, when they get that layer, that the metal articles are called as corroded. So that the process is called as corrosion, okay, especially in case of iron, okay. When iron articles are new, they look shiny, but after some days when they are exposed to air, moisture, acids, what happens? They get corroded or they get the layer of rust, which is brown in color. Okay, so likewise, for examples, we have copper. We all have copper utensils or other copper articles in our house. So when they get oxidized or when they are exposed to air, moisture, okay, what happens? They get green color layer. Okay, so that is the case, that we can see in case of copper. Okay, in case of iron, it is brown color. So this was all about corrosion. Now corrosion can damage cause to car bodies, iron railings, say, then other articles of iron, okay, bridges, even iron, whenever there is iron in monuments and other buildings. So corrosion can cause damage to all these things. Okay, so this was all about corrosion. Now also how to prevent corrosion. Okay, there are some methods to prevent corrosion, like galvanization, then painting, greasing. So by these methods we can prevent corrosion. And next topic we are going to see is rancidity. Okay, now what is rancidity? Rancidity means in case of metals, we have seen when they get exposed to air, moisture, they get corroded. So in case of food items, especially fats and oils, okay, so when they are kept at room temperature for longer time, okay, what happens? They get oxidized. Means what? They get rancid. So when the food items or fats, oils gets oxidized, okay, so that is called as rancidity, or the food items are said to be rancid. So the process is called as rancidity. Now how to prevent this process? How to prevent the food items from getting oxidized? So for that we have to we have to use antioxidants to prevent them from getting oxidized. So the antioxidants will prevent food items or food substance from getting oxidized. Okay, so they prevent the rancidity. Okay, so this was all about corrosion and rancidity. Okay, yeah. So in this chapter we have seen about all types of reactions, their examples, how they take place. Okay, and also about corrosion and rancidity. So this was all about the different types of reaction and corrosion and rancidity from this chapter. Okay, so with this we finish this chapter, which is called as chemical reaction and equation. I'll come with the next chapter in next video. Thank you for watching our video. Okay, please like, share and subscribe. Thank you.